To start with today, okay, to start with for our notes, we're going to start with Unit 6.2a, okay, and 6.2a is using properties of rational exponents. Using properties of rational exponents. Does anyone have any idea what that means in English?
Are we adding exponents to this?
We're not going to add exponents, no. Okay, so what does the word rational mean? Fraction. So we're going to be using the things that you learned in fraction exponents, basically. Okay, like, who's cutting these down for you guys? It's just coffee, it's okay. Great, so to start with, your instructions are going to ask you to simplify. Okay, simplify. For example 1, I would like you to simplify the cube root of 104 x to the third y to the sixth. Cube root of 104 x to the third y to the sixth. Simplify. So basically all you have to do here is break it down. So do you know the cube root of 104? Do you just have that one memorized? Yeah, not so much. Okay. So what would you have to do? Start breaking this down. So what multiplies to give you 104? What multiplies to give you 104?
2 and 52.
2 and 52. How many how many things have to be in a group for them to get out from underneath the radical? 3. That's what this 3 tells you. Okay? I don't have a group of 3 things yet, so you have to keep breaking down. Once you've broken something down, cross it out. Then, what does 52 break into?
2 and 27.
2 and 26.
Oh yeah.
Cross it out. You need to break this down as far as it will go. Can 26 break down?
2 and 13.
Yes, 2 and 13. Cross them out once you've broken them down. Can 13 break down?
No.
No. Okay? How about these x's? X to the third is x times x times x. Y to the sixth is you would actually write it out 6 times. All multiplied together. Now, are you probably able to do this in your head? Yes. But just in case, I'm going to show you the super basics on how to do this. So we are looking for 3 identical things. So I can take out a group of 2's. Those are going to get out. What can I take out from x's? How many groups of x's?
3.
1 group. Okay, we're looking for groups of 3, but I take out 1 representative. How many groups of 3 y's do you have?
2.
1, 2. So if we take all these out and rewrite them, out front is going to be a 2. X to the what power?
Third.
Just the first. Okay, we're taking out 1x. And how many groups of y's? 2. Then you need to write what's left behind. So what did not get taken out as far as numbers? 13. Are there any x's left behind? No. Are there any y's left behind? No. Now, I will give someone a late homework pass if they can tell me, whoever can tell me, why is this answer wrong? What is wrong with this answer? David.
Boom. You see the problem here. Very simple.
You're wasting my time. Sarah. Okay, so what's missing? The handle number of 3. If there's no handle number written, it's implied to be a 2. It can't change from being a cube root to a square root. So if you don't remember to write that same handle number in your answer, it's wrong. Okay? Thank you for your efforts. That was great. So this is the actual answer. So this is just, you guys did this in Algebra 1, okay, just breaking down roots. Only difference here is sometimes you're going to have groups of 3s or 4s. Okay, could be even higher if if the problem presents itself. Okay, let's try another one for number 2. Example 2. I want you to simplify 3xy squared cube root. So make sure, those of you with some handwriting issues, be careful here. This 3 is in the root, not out front. Okay, so this 3 is in the handle. Negative 27, x to the 6th, y to the 8th. 3xy squared cube root of negative 27, x to the 6th, y to the 8th. First off, how is this 3xy squared attached to the cube root? By add, subtract, multiply, or divide? Multiplication. So that means anything that comes out from here is going to multiply. So we know that 3xy squared is going to be multiplying with anything that comes out of here. What can I take out of here? What is the negative cube root of 27? Negative 3. Is it okay to have a negative come out of here? Yes, because there would be 3 of them. Negative 3 times negative 3 times negative 3 does work. So we're going to get to take out a group of negative 3's. How many x's do you think I can take out? X to the 2nd, right? So basically we're dividing by 3. Y to the what? 2nd. And is there going to be anything left behind? Are there any numbers left behind? No. Are there any x's left behind? No. Are there any y's left behind? Yes. Y to the 2nd. Don't forget we have to put the handle number of 3. Then you actually multiply these together. So the numbers multiplied together, you get negative 9. X to the what power?
3rd.
Remember, this is like a 1. So when you're multiplying things together, you add their exponent. So x to the 3rd, y to the 4th, cube root of y squared. That's the answer that we're looking for. Question on how I got that? Anyone have any questions on how I got that answer? So hopefully not too bad. Okay, let's try another one. These you may have not seen before. Okay, something like root 4/3. Root 4/3. First thing you want to do is reduce if you can. Can I reduce 4 over 3? Not so much. Okay. Not that you have to write it, but what is the handle number right now? A 2. Okay? It's actually a handle number of 2. A handle number of 1 isn't possible. That doesn't make any sense. Okay? So this is actually a handle number of 2. You don't have to write it in there, but if you want to, you can. Then I want you to break up this large root into 2 little ones. So we're going to write 1 over the 4 and 1 over the 3. Then I want to break things down if you can. Do you know what the square root of 2 or of 4 is?
2.
Just gave it to you. 2 over, do you know what the square root of 3 is?
No.
No. Now, it would be really nice if we were done, but we're not done, okay? There's a rule in math that basically says you can't have any radicals in the denominator, and it's because it's kind of like if you have 0 underneath, something is undefined. Okay, that's like a bad answer in math. Radicals are also a bad answer in math. So you have to do something called rationalize the denominator. Okay, rationalize the denominator. And basically, you have to get rid of the root in the denominator. So right now, in order to get rid of a radical, you have to have a pair of things, right? Right now you only have 1 3. If I wanted to get rid of the radical, how many 3's would you need?
2.
2. So what you're going to do here is you're actually going to multiply by root 3. I want to make a pair of them. Now if you multiply on the bottom by root 3, what else do you think you have to do? Multiply the top. Does anyone know why is it okay to just randomly multiply by root 3 over root 3? Jalen's right. Root 3 over root 3, it's just like multiplying by 1. Okay, we're just writing this in a different format. Okay, we're writing it in like a math acceptable format. That's why it's okay to multiply by 1. Okay, then multiply on the top. Whole numbers do not mix with insides. Okay, so like 2 root 3. over, what happens in the bottom?
It cancels.
They don't cancel out, but it makes a pair, so you just take out 1. So your answer is just 3. The roots are gone because you had a pair of 2, and once you have 2, you can take them out. This is the answer that we're looking for. 2 root 3 over 3. That's called rationalizing the denominator. Okay, let's try another one like that. Number 4. For number 4, I'd like you to simplify the 5th root of 3/4. 5th root of 3/4. So again, first thing you want to do is try to reduce. Can 3 over 4 reduce? No. Next thing you want to do is break this into 2 little roots. So 5th root of 3 over the 5th root of 4. In order to get out the top, I don't really care about the top. Okay, you can have radicals in the numerator and that's totally fine. The denominator is the problem here. Right now I have the 5th root of 4. Do we know what the 5th root of 4 is? No. To get rid of the radical in the denominator, what do I need to have? I need to have how many identical things? 5. So what do you think you would have to multiply by to get 5 identical things?
5.
Not by 5. Say it again. Can I just multiply by the same thing? Don't write this down. If I multiply by the 5th root of 4, I would get the 5th root of 16. Do I have 5 identical things yet?
No.
No, this is 16 is what? 2 multiplied by itself how many times? 4 times. So it's a problem. I have what? What does 4 break down to if you broke down the numbers? 4 is 2 times 2. So how many identical things do I have? 2. How many more do I need? 3. So here, rationalizing the denominator, you have to figure out what do you need, okay? And here, I actually need to multiply by the 5th root of how many 2's? 1, 2, 3 of them. 2 times 2 times 2. What's a kind of easier way to write that? The 5th root of
8.
8. Okay, 2 times 2 times 2 is 8. Can you write them all out? Totally fine. Then, in the numerator, you multiply. So multiply across the top here. Don't forget, you still have a 5 in your radical, in your handle. What is 3 times 8? 24. Over what? If you multiply these together, I have 5 identical things, so I take out the representative, and what's left in the denominator? Just a 2. Okay? Can you break anything out of the 24? No. Okay? If you could, you should. But you're not going to have to break anything out of the top there. That's the answer that I'm looking for. Okay? So you have to figure out what's missing from the denominator in order for you to get rid of it. Okay? In order for the radical to be completely gone, what would you have to multiply by? Okay? Just a couple more for you guys. Everyone good up till here? You're not so ready. Okay, for number 5. Okay, number 5, I would like you to simplify 15 over the 4th root of 27. 15 over the 4th root of 27. 15 over the 4th root of 27. Can I reduce anything to begin with? No. Okay, whole numbers can't reduce with radicals. So here, what do I actually have? What does 27 break into?
9 and 3.
What is 27 completely broken down? 3 times 3 times 3. How many identical things do I have to get rid of the radical? 4. So what do you think I actually have to multiply by? 4th root of 3. You still have to have that same radical, or the same number in the handle, but I only need one more here. Multiply by the same thing in the numerator. Then, go ahead and multiply together in the top. So 15, 4th root of 3, over what?
3.
1, 2, 3, 4 of them. So I can take out a whole 3. Now, this one's just a little bit different. Why, do you think?
Because it can reduce.
Because they can reduce. Okay, the 15 and the 3 can actually reduce. Radicals do not reduce with whole numbers, but these are both whole numbers, so they can reduce. 15 over 3 becomes what? Just 5 fourth root of 3. That's the answer that we're looking for. Yes.
Can roots simplify with themselves? Like if you had root
Yes,
3
if you
over
have-
root 15, would
Yes.
that reduce?
Yes. If two things are underneath the radical, yes, they would reduce. Right? Last one I want you to try for, oops, sorry, not example 7. What are we
But
on?
what
6,
about
sorry.
handles? Can you reduce handles? Or
Handle numbers do not reduce, no. Those are just guidelines to tell you exactly like how many things you have to have. Okay, last one. I'd like you to rewrite or simplify 3x to the negative 1/2. 3x to the negative 1/2. Simplify 3x to the negative 1/2. First things first, what do you do whenever you have a negative exponent? Yes, we'd like to make it positive, but how do you do that? Make a fraction and move what? Anything attached to the negative exponent. So what's actually going to move here to the bottom? Just the x to the 1/2 power. The 3 stays on the top. The exponent is only attached to the x, okay? Then, to simplify this, I want to rewrite it in power handle. So this would become 3 over root x, power of 1, handle of 2. Is it actually necessary to write in the power handle there? No, it's the same thing. But what's wrong with this? Can't have radicals in the denominator, so how would I get rid of the radical in the denominator? Multiply it away. So what would you multiply by? Root x over root x. In the numerator, right, and it has an invisible 2 as the handle number. If you don't write the handle number, it's implied to be a 2. So in the numerator, you have 3 root x over, what's root x times another root x? Just an x. And can you reduce that? No. That's your answer. 3 root x over x. For this part, okay, for this part of notes, your homework is in your green book, okay, not the actual big book, but the worksheet book. You're working on worksheet 2A, and you're doing the odds, 1 through 30 odd. Okay, you'll have to look in your green book, and they're not all numbered exactly the same, so it's Unit 6, Worksheet 2A. Unit 6, Worksheet 2A. Anyone have questions on that?